Sorry, this is also clunky. All right. So got a 20 ml aliquot of a concentration of sulfuric acid. So this is our known one this time. We've got the volume and the concentration. We know the concentration, and this time it's down in the conical flask. So often they put the thing that they know the concentration of, the standard, up here, but this time they've put the standard down there. These questions so far are easy. They're putting the solution with its concentration right next to the volume. So you don't have to look far to find the volume of this, but on the exam they're not going to make it that easy, so they'll write a whole lot of stuff and they'll separate probably the volume and the concentration. So because you're going to have two volumes, the aliquot volume and the titer volume, you really need to be careful which goes with the standard. Alright, so we've got our sulfuric acid that we know the amount of down here, H2SO4, and we're trying to find our ethanamine up here. So our unknown is up here. S2 up here. I'm going to move this in a minute because it's a bit clunky. Anyway, so when we do our balanced equation, so you need to be able to write balanced equations for these. This one will take one hydrogen ion and your sulfuric acid's got two. So the sulfuric acid, SO4, 2 minus, you know that it's 2 minus because you need 2 and that each one of these is 1 plus. So this must have been 2 minus. So when one hydrogen is accepted by the nitrogen and it becomes NH3 plus, so this is an ion, H2 NH3 plus. This will have to happen twice because we've got two hydrogens. Okay, acid plus a base makes normally a salt and water, but this one is just making a salt. So the hydrogens have come from here, been accepted by there, so that you get positive ions, and then you're left with the negative sulfate ion, SO4 2 minus, which means that you need to have have two of these. So we show that we've got two of those, and which means you needed to have two ethanamine molecules. Wow, that took a while to explain. All right, so move my clunky pieces of paper, get a spare piece of paper. Okay, so our known one, the sulfuric acid, H2SO4, is our aliquot, and our unknown is the ethanamine. I shouldn't look at the screen, it's really weird. Oh, 2 ethanamine. Okay, so given the average titer was this, calculate the molar concentration of the ethanamine. So they're not giving you steps here, they're going straight to this. So we have to do all our steps first. We need to know the number of moles that was down in here to start with. Then we need to use our ratio to work out how many moles we needed. And then once we've got the number of moles that we needed, then we can use that volume to work out the concentration. So they haven't given you 3 questions. They've just straight away asked for this. So you need to know that there's 3 steps. Okay, so first of all, finding the number of moles of your known, your sulfuric acid. So it's up the top there. Just multiply those together and you get the number of moles. Make sure you've got the correct number of significant figures. So the concentration is only to 3. So all our answers will be 3. You keep all of your numbers in the calculator though. Then we do our ratio. So going from our known to our unknown, you put what you want on the top. So we want this, the ethanamine, it's very hard to say, which is a 2. So this number goes with that, to 1. You don't need to write this out, but you do need to show at some point either that or this, that the number of moles of this is twice the number of moles of that. So it's 2 times this. So you've got the number of moles of here. So you've done your ratio, going from your known to your unknown. And then we just put this over the titer in litres, and then make sure you've got your 3 significant figures and your units moles per litre. Alright, that'll do.